Hey, so one day it occurred to me that it would be prudent to remotely set off some of the incendiary compounds I've been trying to synthesize. Stuff like black powder, different types of thermite, and also acetylene gas produced from calcium carbide. A strand of fine steel wool can be ignited with a single 9-volt battery. Instead of using long wires to trigger the ignition, we can do it remotely. An Arduino is used to detect when a button is pushed, and that information is sent via radio waves using a pair of HC12 modules. The receiving unit recognizes the instructions and activates a relay that allows current to flow from the battery to a strand of steel wool. Each unit is hooked up to a power bank, and 4 additional 220 ohm resistors are used on each board just to prevent the bank from going to sleep mode. Placing them between power rails allows for a higher consumption, and consequently the resistors heat up slightly. 2 caps are added for power filtering according to the schematic. Next up, here's the code running on both Arduinos. I designed a pair of rudimentary enclosures in Fusion 360 and printed them using a neon lime PETG filament. For anyone wondering, this was done on an Ender 3S1 Pro. The receiving unit is connected to an add-on board to allow for simple repairs and steel wool swaps, as it will probably get damaged by the burning compounds. Instead of using steel wool and replacing it after each ignition, a thick enough nichrome wire could be used multiple times. Doing so, however, I'd recommend swapping the 9-volt battery for at least a single C or D cell. This will make the receiving unit quite beefy unless you figure out a way to use the already included power bank. There's room for improvement. Anyway, I hope this helps, and a little disclaimer, I take no responsibility for your nefarious shenanigans. Well, the add-on board got obliterated after a single use. No worries, here's some homemade thermite in action anyway. As it turns out, it's very hard to successfully ignite steel wool in this manner, as opposed to just using it to short-circuit the battery. I just could not get it to work reliably. The remote mechanism works fine, but the igniter needs major revisions, so let's do just that.
A few moments later.
So I went and visited a vape shop. Believe it or not, they actually sell some useful stuff, like various types of resistance wire to serve as heating elements. Supposedly, nichrome, kanthal and stainless steel are used. However, they can be pretty thick since they are used with 18650 lithium-ion cells, or similar, which output significantly more current, albeit at a lower voltage. I got my dirty grabbers on some pretty thin 28-gauge stainless steel wire and used it with 8 AA batteries wired in series, since I just happened to find the appropriate holder which still fits in the same plastic box. Since I needed more current, I also upgraded the wires. Too high of a voltage, on the other hand, isn't really beneficial here. The wire is used to make electric matches, but instead of packing crushed match heads around it, I opted for some DIY rocket candy, since it's really cheap and easy to make in bulk. This time I also came up with a contingency plan, which is to replace the wire with a 5 ohm resistor or a value close to that, probably 10. Either way, everything is wrapped in duct tape. While the remote control system somehow worked flawlessly, the igniter needed upgrades. Since most research articles published online only tell you about successful endeavors while omitting the failures, I thought I'd do the courtesy of stating what not to try, since I can't really do that in my line of work. Anyway, enough of my rambling and thanks for watching.